Alright, so this is going to be our second video for Math 1560 Calculus 1 at U of L Fall 2017, where we use the definition of the derivative to compute the derivative of a function. And this time we're going to tackle the square root function. Okay, so same as last time, we'll calculate the derivative at a point, then we'll calculate the general formula. So let's do f prime of 4. So what does the definition say? The definition says that this is the limit, h going to 0, f of 4 plus h minus f of 4 over h. Okay, so f of 4 plus h, I take 4 plus h, I stick that under the square root of 4 plus h, and of course the square root of 4, that's just 2 over h. As you expect, you get a 0 over 0 limit, so we have to do some algebra to get our answer out. So what do we do whenever we see a square root? Well, one of the things we always try is whether we can rationalize. So let's see what happens. I take root 4 plus h minus 2. I multiply by root 4 plus h plus 2. But of course, anything I do to the top, I must also do to the bottom if I don't want to change my limit. So now we multiply things out. What do I get on the top? I get, well, the square root times the square root, though the square root squared makes the square root go away. I get simply 4 plus h. My cross terms cancel, right? This gives me plus 2 times the square root. This gives me minus 2 times the square root. And then minus 2 times 2 gives me minus 4. And write down the denominator, and now we start canceling. So notice that I can cancel those 4s. Leaves me with just plain old h on the top once the 4s disappear, and then of course h divided by h, I can cancel those as well. Probably we should do those in 2 steps, but as you can see, I've only got a couple inches of space left here on the page, so I'm gonna cheat. I'm left with 1 on the top, square root of 4 plus h plus 2 on the bottom, and now I can let h go to 0. There's no problem here. If I let h go to 0, I get the square root of 4 plus 2. I get 2 plus 2 in the bottom. I get 1 over 4 for my limit. So that gives me the derivative of my function at that point. Okay, now let's try to do the general calculation. So I'm doing the limit, h going to 0, f of x plus h minus f of x, all divided by h, and we plug in our function. So the square root of x plus h minus the square root of x over h. And again, I'm going to need to rationalize, so let's do it right here on this line. I'm going to multiply by root x plus h plus root x, and I'm going to do that top and bottom. Okay, so let's multiply things out. On the top we get a difference of squares, and when we square these guys, the square roots go away. X plus h minus x, cross terms cancel. Root x plus h plus root x. And I can cancel those x's. Leaves me with the limit. I'll do it in 2 steps this time. I've got h over h times x plus h plus root x. Let's cancel those h's. I get the limit as h goes to 0 of 1 over square root of x plus h plus the square root of x. And if I set h equal to 0 here in this limit, which I now can do, we see that we get 1 over root x plus root x, so we get 1 over 2 times the square root of x. And this calculation is going to work no matter what x value I plug in, as long as x is positive, right? I can't take the square root of a negative. I can't divide by 0, so x has to be bigger than 0 here. But for any positive value of x, this will work. So as sort of a follow-up example, let's say I wanted the slope of the tangent to y equals root x at x is equal to 3. What is that slope going to be? That slope is going to be f prime of 3, which is 1 over 2 times the square root of 3. And if we want, we could even give the tangent line, right? What's the equation of the line? Y minus the y coordinate. So if I put x equals 3, y is equal to root 3, equals the slope, 1 over 2 root 3, times x minus the x coordinate, x minus 3. And we have the equation for our tangent line. Okay, we'll do a couple more of these examples before we move on.